Okay, so I wanted to do a little quick video on Taylor polynomials. I use the notation T3 for Taylor polynomial of third degree because we have a third power that will end up in the problem, and we will also end up with a third derivative. So if I said T4, that means we're going to need the fourth derivative, so on and so on and so on. Okay, so this is the notation. I think your book uses P, like P sub 3 and P sub 4 and so on and so on. I just choose to use this notation because it's from the Stewart book, but if you're doing the online homework, you're using Briggs, and Briggs has chosen to use P. But these are called Taylor polynomials, and you'll see why in a second. And you can use them to try to approximate or represent a function. So in this case, we're going to try to represent sine x using T sub 3. So what I'm going to do first is I'm going to have to take the derivative of sine of x. So I'm going to rewrite here. We got sine of x. We know the derivative of this is cosine of x. We know the derivative of this is negative sine x. And we know the derivative of this is negative cosine x. Okay. And remember, we're looking for T sub 3. We're looking for a third degree Taylor polynomial, or a polynomial using the third derivative. A Taylor polynomial using a third derivative. We're centered at pi force, so we're going to use pi force to plug in. So that means we're going to have f of pi over 4, f prime of pi over 4, and these will give us our coefficients, and f triple prime of pi over 4, okay? So we know this is going to be square root 2 over 2, square root 2 over 2, negative square root 2 over 2, and negative square root 2 over 2. So those are our coefficients that's going to go in front of each of the terms of the Taylor polynomial. We know that we're going to have f of pi over 4, which would be square root 2 over 2 times 1 over 0 factorial, plus square root 2 over 2 times, let's see here, x minus pi over 4 all over 1 factorial minus square root 2 over 2 times x minus pi over 4 squared 2 factorial minus square root 2 over 2 times x minus pi over 4 cubed, and that's where we get our third from, right? Or third degree Taylor polynomial. And this would be 3 factorial. Okay, so then we could factor out a square root 2 over 2. They all have it in common. And that would leave us behind 1 plus x minus pi over 4 minus x minus pi over 4 squared over 2 factorial minus x minus pi over 4 cubed over 3 factorial. And that would be our T sub 3, our Taylor polynomial using the third derivative. Okay, and then like a follow-up question they might say is, use this now to approximate sine of, you know, something close to pi over 4, and then you would go ahead and do it. Or they may ask you to find you know, the general Taylor series for this, and then do the integral of convergence. They can ask you anything after this, but we're just finding T sub 3. So this is a little bit more straightforward. It's just showing that we know how to build a Taylor polynomial from scratch without memorizing some special formula for e to the x with a Maclaurin or something. We're just demonstrating our ability to build one from scratch, okay, where they came from and how to make it. So you guys should pause the video now, try this one on your own without me walking through it. Okay, and once you do that, unpause it, and then we'll go through it together. Okay, so hopefully you guys have unpaused the video. So we now have f of x equals x to the negative 2. The derivative of that would be negative 2x to the negative 3. The derivative of that would be 3 times 2 x to the negative 4. The derivative of that would be negative 4 times 3 times 2 x to the negative 5. And this is a good habit to get in, guys, is writing out these terms. So it starts letting you recognize you're dealing with something that behaves like a factorial. So then you can kind of use that to cancel the other part of the Taylor series in there. You know how the Taylor series has divided by n factorial. So when we plug 1 into this, we get 1. When we plug 1 into this guy, we get negative 2, we get 3 times 2, and this one we get negative 4 times 3 times 2, because the plugging in 1 for x just makes it the same. So now we're going to write out our Taylor polynomial. So we're going to end up with 1 over 0 factorial minus 2 times x minus 1 over 1 factorial plus 3 times 2 times x minus 1 squared all over 2 factorial minus 4 times 3 times 2 times x minus 1 cubed all over 3 factorial. Okay, so then our official t sub 3, if we want to clean it up, this is actually the answer, but if we want to clean this up a little, we could cancel this and this, right? So then we would have 1 minus 2 times x minus 1 plus 3 times x minus 1 squared minus 4 times x minus 1 cubed. And that would be our Taylor polynomial t sub 3, okay? And that's what we're saying would be a good representative of this, centered around x equals 1. So as long as we stay around there, obviously we didn't find the interval of convergence, but we're hoping that it's somewhere close to 1, we're okay. So this would be a good representative of that. And then somebody could ask you to approximate 1 over 1.4, right? And you could do that. So in this next problem, that's what we're going to do. This is a homework problem you guys have, or something similar to it. And I believe I asked something like this on the exam. So in this problem, they actually say use the given Taylor polynomial. So for this one, they give you the Taylor polynomial p sub 2 to approximate the given quantity. So they want us to approximate 1 over the square root of 1.02, and they're telling you that the Taylor polynomial for 1 over 1 plus x is 1 minus x over 2 plus 3x squared over 8. They're giving you p sub 2, or in my case, I'd say t sub 2, okay? So we're going to use that to approximate it, and then they want us to find the absolute error. So I don't think I've talked to you guys about absolute error, but you'll see why. It's no big deal. I just wanted to make sure you know. And if you see this on the test, it's not the first time you've ever seen it. It's very straightforward. So says using P2, approximate 1 over the square root of 1.02. So we know this is 1 over 1 plus 0.02, right? So 1.02 is the same as 1 plus 0.02. So that means this is my x, right? My x is worth 0.02. So then I'm going to take p sub 2 of 0.02 and plug it in. And I get 1 minus 0.02 over 2 plus 3 times 0.02 squared over 8. And let's see what we get on our calculators. We get 1 minus 0.02 divided by 2 plus 3 times 0.02 cubed or squared divided by 8. So I get approximately 0.99015. Well, I get this exactly, but this is an approximation to this, right? Or to, yeah, to that. I'm sorry, that is correct, to that. Okay, so I plug this in my homework, and it tells me that the answer is 0.99015. So this is my approximation to 1.02. So then they want to know part B, absolute error. So all you do is you take the absolute value of whatever the calculator gives you for the correct answer. So I'm going to take the calculator's answer for 1 divided by second function square root of 1.02. Oops. And I get 0.990147543. And this is from calculator. So the calculator did this 1 over the square root of 1.02. And now I'm going to subtract off my calculation of 0.99015. So I'm going to say minus 0.99015. And I get 2.4, and it says round off to 2 decimal places in my homework. So it'd be 2.46 times 10 to the negative 4. Oops, negative 6, I'm sorry. And this would be my absolute error. So all you have to do to find absolute error is my value from P2. All you have to do to find absolute error is plug the actual number into your calculator, and you'll get this, right? And then you take what the polynomial told you the approximation is, which is this, right? This comes from here. Okay, so you take those two guys and subtract them, and whatever value you get, that is called the absolute error. So it's pretty straightforward. So as you can see, the Taylor polynomial only using P sub 2 is already pretty darn close to the actual answer. So this is how you can approximate things using Taylor polynomials. You can kind of start seeing the possibilities for this. And then the error involved was pretty good. We have a pretty good error. So this is just something that I'm planning on asking you on the exam. And I do not believe I went over it. It is in the homework, but I wanted to do one of these. So please take a minute to watch this video, or I should say thank you for watching the video. And maybe go back and see if you can do these problems yourself, and then double check that you know how to do the ones in the homework, because there will be test questions like this.